My name is Alyssa, and this is my Lab 8 optical testing with Shear plate interferometers lab video. So the objectives for this lab are to use a wedged and non-wedged shear plate interferometer in order to observe spherical aberration of a lens based on its shape factor, defocus, decenter, and coma. For a non-wedged shear plate, the optical path difference is going to be the difference between that first reflection wavefront and the sheared wavefront. Now, similarly for a wedged shear plate, it is going to have the optical path difference, once again, between that first reflection and the sheared wavefront, but additionally, it is going to have this 2n beta also subtracted from it, which is based on the wedge angle. Now, for this lab, we are going to go ahead and have two different setups for a wedged and a non-wedged shear plate, but they are both very similar. They have a laser, a beam expander, a collimating lens, mirror, and then an interferometer. So first of all, we have the non-wedged data points. So looking at this points going from residual to defocus, we can go ahead and see that there's actually going to be some change in those points. Now in the shapes. Now when we look at the residual to decenter, there's really just shifting along. It's not actually changing the shape. For decenter and defocus, there's going to be a combination. So there's going to be the change in shape from the defocus and then the shifting from the decenter. Next up, for the wedge, it's very similar in that the defocus actually is going to have a shape change. And as we can see here in the bottom left, that shape is actually going to be more S-curved, and meaning that it is more flat in the middle, which is what we want, and is going to be curved from the spherical aberration. We can see the shape changing though, versus once again, that decenter is just going to be shifting. For some example calculations, we went ahead and used this example, which was for a non-wedge max spherical aberration and had a defocus amount of 3.29 millimeters. Putting it into the MATLAB code that we created, we found that it has the spherical aberration, coma, defocus, and tilt coefficients. We put it into Professor Wyant's simulation and found this graph, which is fairly similar to the interferogram we found. Thanks for watching.